And good morning, good afternoon, good evening, and possibly good night, depending on when you're deciding to do these lessons. Remember, it is always healthier and advisable that you are doing these lessons between 8:25 and 2:30 as per the school day, but I appreciate that these are different times. So whenever you're doing this lesson, I'm glad you're doing it. So today's lesson is on energy. This is the second in the series of lessons. So lesson 1, if you remember, we spoke about energy stores. This is lesson 2, and we're going to talk about energy transfers. So within those stores, how does the energy transfer, essentially? So the challenge is explain the conservation of energy, which is a law, and our aspire today is identify which stores increase and decrease during energy transfers. There's a keyword that I'm going to use as well. Those energy transfers occur through pathways. Okay, so they're called energy pathways, and we'll talk more about that. But so today what we're going to learn is about how energy is transferred. And as usual, with all lessons, what we need is a pencil and pen. You won't need a ruler today, just a pencil and pen. And our starter, we're going to recap the previous learning from the last lesson. So I want you to you can either jot down these 4 words: kinetic. These are different energy stores, by the way. So kinetic, magnetic, nuclear, and chemical. And what you're going to do is I'm going to give you a certain amount of time, probably 30 seconds, to match these words with the following images. So we have got an image of petrol or diesel, got an image of a runner, we've got a power plant of some sort, and we've got a levitating earth. Okay, so I'm just going to give you 30 seconds to match the correct image with the correct word. And what I'll do to help, I'm just going to number them. So there we go: 1, 2, 3, 4, and your time begins now. So there we have, our 30 seconds are up. So let's look at these terms and see if we can match them with the correct images. So what we've got, the first one, and I'll do it, how shall I do this? I'll do this with the numbers. So number 1, we can see it's petrol or diesel. It's actually unleaded petrol. And do you know how you know that? You know that because here, there is, the handle is green. So if you ever go to a petrol pump, if you have a look, the green handle is unleaded petrol. The black handle is diesel. It gives you an idea of which one you should be putting in your car, because obviously you wouldn't want to put the wrong one in. If you do put the wrong one in, like I very first did when I first had a car, you need to call out someone, and it costs you a lot of money to fix it, because it can ruin the engine, because they have different boiling points and combustion points. So it's really important that you put the right fuel in your car. Anyway, I digressed. So number 1, we've got unleaded petrol, and that would be chemical, because the chemical bonds that are broken therefore releases that energy. So we've got chemical there. Number 2, we've got a runner. They are moving, so that makes it kinetic because they are running. There's my little arrowhead. Number 3, we've got a nuclear power plant, so that is nuclear. And number 4 is, I'm sure you got that one, is magnetic. And there we go. So they are our link ups from last time when we talked about different types of energy stores. Okay, so that was last lesson. Let us continue with today's lesson. So like I said, what we're going to be talking about are energy transfers. However, although we labeled those 4 stores, I think that's quite a simplistic model. However, energy stores move within a system. So when you've got transfers, it occurs within a system. And there are, we have learned the 8 different types of energy stores that are required to be known. Now, what I want to do is, if you haven't got those down currently, get those written down whilst I'm talking. So we've got chemical, kinetic, gravitational, elastic, thermal, magnetic, electrostatic, and nuclear. Get those down, because what I'm going to show you is I'm going to show you a small clip of a cartoon, actually. Coyote and Roadrunner. I used to watch it when I was a kid. But basically, it's a little cartoon. What I want you to do, whilst watching that cartoon, I want you to note down what energy stores you can see. And if you can, how there are energy transfers occurring. So at any given point, there might be something happening in that video, and it's only a minute long. There might be something happening in that video. I want you to describe the energy store that you can see. There are lots of different energy stores. I'm not expecting you to get all of them, but just get some of them down and see if you can match the energy stores that you have learned to the video that I'm going to show you. So I'll count you down to that video. So 3, 2, and 1. Okay, so hopefully you watched the video. It was very short. If you didn't manage to get those energy stores written down and you perhaps want to watch it again, just pause the video, just go back 1 minute and watch it again. That's absolutely fine. I'm just showing you the chemical stores, because I'm reading it off the slide, the energy stores in front of me. The reason why I'm going to do that is that we're going to watch the video again now, and I'm going to talk over it. Whilst I'm talking over it, I'm going to just highlight, not all of them, by the way, not all of them. I'm going to highlight some of the energy stores occurring in that video. And then you can see whether you can tick them off as you go along to see whether you've got them right. It would be quite interesting to see your thoughts on it. So what you're going to do is we're going to watch the video again, but I'm going to talk over it. So here we go. We've got Coyote laughing, thinking it's rather funny. And then all of a sudden, Roadrunner comes in, scares him, and he's up. Look where he is. Because he's high up, that's gravitational potential. Okay, so we've got some gravitational potential occurring here. Now he's put some food down. We've got a chemical energy store here. So a chemical energy store. He's here. Whilst he was running, by the way, that was kinetic. So you can see his head bobbing. That's kinetic. Now we've got Coyote coming round to eat him. He's scared. He's jumped up. As he's jumping up, it's gravitational potential. He's running away. That's kinetic. Now look, he's bouncing up and down. That's elastic. So that is elastic. That's a rebound. And here's more elastic. So there's an elastic potential occurring here because it's a mouse trap. Snap. Oh dear, it's a big rat. So what's going to happen? He's going to get compelled, and that's the elastic potential, and there's some kinetic with that. Okay. So that was a brief overview of some of the energy stores within a given situation. Now, obviously, there were lots of situations there, but to get on to energy transfers. So, as well as energy stores, we have energy transfers. Energy can be moved from one store to another using energy transfers. Um, Another word that I wouldn't mind using here is pathways or via pathways. When energy is stored, nothing happens. To say, for example, um, if you've got gravitational potential energy, it might be at that point you've just got an object that's high up. Nothing is happening because it's just staying high up. So if I was holding my mobile phone, I put it up in the air, it's got gravitational potential, but that's it. Hence it's called potential. So when energy is stored, nothing happens. It is only when energy is being transferred via a pathway that things start to happen. Nothing happens when the energy is stored. It has to be transferred or along a pathway for something to happen. Now, there are four pathways energy can be transferred via: electrical, mechanical, radiation, and via heating. So they are the four pathways that energy can be transferred. So I'm not talking about, I have to be really clear here. There are energy stores such as kinetic, gravitational potential, thermal, nuclear, and so on. They will transfer energy to different stores. So say, for example, from gravitational potential to kinetic, and it might occur via a certain pathway. So it might occur via electrical pathway, or a mechanical pathway, or via radiation pathway, or via heating pathway. So I'm hoping you understand that concept. If not, you really need to re-listen to this slide again. So I'll repeat that again. So what you've got is you've got energy stores. Those stores will increase and decrease. They only increase and decrease because energy is being transferred via four different pathway routes, you could say. So from A to B, it needs to go via these roads, so to say: electrical, radiation, mechanical, and heating. Now, at this point, it's really important that I bring up the law of conservation of energy. As a statement, you need to remember this. So if you're going to write it down, this is a key fact that you need to write down. Throughout all your time of learning physics, whether it's GCSE, whether it's A-level, whether it's fundamentally anything else, or regardless of academic usage, in real life, so to say, you need to understand the idea that energy cannot be created or destroyed. So we never say, oh, that food created energy, or respiration, this is a classic, respiration creates energy. Okay, it never does. It may release it, that's a different word. Releasing is different. Creating is making something from potentially either something else or nothing. So energy cannot be created nor destroyed. It can only be transferred from one store to another. Now, this goes back to the point that I made earlier. Just because something is not happening doesn't mean it doesn't have energy. Does that make sense? So I'll say that again. Just because something isn't happening does not mean that it doesn't have energy. It will just have it as potential. So say, for example, if I pull an elastic band back, okay, so if I pull an elastic band back, it's not moving at that point, but does it have potential energy? Yes, it does, because the moment I let go of my finger, it will fly forward and it will transfer that elastic potential energy into kinetic energy, because then it'll be flying through the air. Okay. I do quite like the GIFs, I have to admit. In theory, because energy can't be created or destroyed, it can only be transferred. When you've got a certain pot of energy, unless you're going to add to it, that's what this pendulum is showing, there is absolutely no way in the second GIF that should ever hit him. It will just never happen. But obviously it does. Right, so a classic way of showing this, or a classic way of showing the the increases and decreases during energy transfers from one store to another, is by using a pendulum. Now, you can do this yourself. You can get yourself, and it's really easy to do, get yourself a piece of string with a conker, say, it's not really conker weather, is it? But if you've got something that you can put on the end, be it blue tack, whether a ball or something, sometimes there's a dog toy that has got a string with a ball on. Basically, that's all you need to do. Then what you need to do is you need to hold it up in the air, and then just give it a little push from one side to another. And then you've created a pendulum. What I want us to think about, though, is this. What is the energy store when the pendulum is pulled to one side at the start? So, looking at my diagram, I'm going to get this pendulum and I'm going to place it here. And I'm going to call that 1. Okay, so my pendulum is there. Now, I'll draw the line so it makes it a bit easier. There we go. So my pendulum is there. What is the energy store when the pendulum is pulled to one side at the start? Now think about it. It's there. I'm holding it. What have we got? I'll give you 5 seconds. Hopefully, you came up with gravitational potential. Number 2, what is the energy store when the pendulum reaches the bottom? Now, I'm not going to give you the answer to this. I've worked through number 1 with you. What I'd like you to do is I want you to think about that question for number 2. And then the third one, why won't the pendulum swing forever? So I've got 3 questions and the timer starts now for you to answer them. 30 seconds. Right, so let's have a look. So number 1 we spoke about, it was gravitational potential. And actually I'm going to show you another diagram. So what we've got here, same pendulum demonstration here. However, I've just got a little bit extra text. So what we've got is the gravitational energy store from being up high. Okay, so when it was up here, it had a gravitational potential energy store. Now what happens when I let go, that store, so that store there decreases. Okay, nothing else has changed apart from the height. That's really important to understand. So if the pendulum, I should say, was here in comparison to here, the height is lower. Okay, so there's the height and there's the height of the other one. So the height is lower. Because that height is lower, it means that the gravitational potential energy has decreased. Okay, that's a simple fact. Where has it gone to? Well, it is transferred to the kinetic energy store, and that's because it is moving. Okay, and as it moves from here down to here, what do you think is happening to the pendulum? Well, the likelihood is, due to gravity, it should be accelerating. Okay, so if it is accelerating, so follow me, if it is accelerating as it falls, what happens to the kinetic energy store? Well, it's going to increase. So you've got the gravitational energy store decreasing as it falls, but you've got the kinetic energy store increasing. Now, by the time it reaches at a perpendicular to there, so a 90-degree angle there. So as it reaches there, I know that's not exactly straight and it should be straight. As it reaches there, it is at its maximum kinetic energy store. The gravitational potential energy is at its lowest. Now what happens as it moves this way? Well, it will start to decelerate. Now, and it gains height. So because it's decelerating and it's gaining height, what is happening to the stores? Well, the kinetic energy store is decreasing. The gravitational potential energy store is increasing. Okay? And then again, as it reaches the top point, at one certain second, and I say second, it might be a millisecond, but at one certain point, it will feel that it has just stopped in midair. At that very point, the kinetic energy store is at its lowest, and the gravitational potential energy store is at its highest, and then it would start to fall back. Now, that third question was about, well, why does it not swing forever? That is because it would only swing forever in a vacuum. Now, a vacuum is a space with no air particles. Simple as that. Now, because it has air particles, what is that pendulum hitting? Well, it is hitting the air particles, and that causes air resistance. Okay, that air resistance, effectively, energy is again being transferred into the air. Okay, so therefore it's going to slow down. Without getting too technical, that's the premise of it. So let's just take it as air resistance for the moment, because there's a lot of other concepts that we need to make sure, and that is why it would slow down. And we'll talk more about air resistance when we move on to energy in 9, 10, and 11 in particular. So I hope you understood that. If you didn't, go over this slide, because fundamentally this is the most important slide of the PowerPoint. So hopefully with that understanding, what I want to do is I just want to consolidate that. So describe the energy transfers in these two images. The first image that you're going to see is the train was moving. The second image is the car is accelerating from a standstill. So you can see that the train was moving. It was clearly moving a bit too quick, and it came to the end of the station and it hit the buffer. Okay, so there's a buffer that stops it from, ploughing into the pedestrians who would be on the other side, or passengers. So what I want you to do is describe the energy transfer in that image when the train is moving. And then B, that car is accelerating from a standstill. You can see the burning rubber. I want you to describe the energy transfers for that. Now, what I'm going to give you is I'm going to give you 1 minute to do so. Jot them down really quickly. And then I will give you a 30-second countdown when that arrives. You can begin. And your 30 seconds. So there we go. So let's have a look and see what we've got in terms of our answers. So the first question was describe the energy transfers when the train was moving. There's the image of the train. Now I like to draw pathway diagrams. I've never shown you this, so I wasn't expecting you to do this. However, this pathway diagram explains where the energy goes. So what you end up having is you start off with a kinetic store. That's the moving train, because I said the train was moving. So therefore, if the train is moving, it is a kinetic store. However, in that diagram, and I hope that most of you got that bit, in that diagram, or sorry, in the image, it's not a diagram, in the image, it hits the buffer. Now at this point here, where it says the train hits the buffer, okay, so at this point here, we have some energy transfers occurring, and they go into 3 different stores. So the first one is it's slowing down. Now, if it's slowing down, there's going to be friction with the wheels and in the springs. So what you've got, where Where's my mouse gone? Here. Oh, there we are. So we've got a thermal store. So because friction is occurring, heat is being given off. Yeah. And that occurs in the spring. So some of the energy is being transferred to the thermal store. Now, look at that diagram. That train clearly hit the buffer, the black part, you can see here. Okay, so the train was moving in this direction. It hit the buffer, but however, it's ended up back there. Now, why? And that's because the energy would have been transferred into the buffer, and then that basically, even though it doesn't look like an elastic band or anything, because there's a compression of it, it pushes the train back. So that's your elastic potential store. Okay, this is actually quite a difficult question. So that's your elastic potential store. The reason why I'm asking this is because you can see how it explains why the train ends up in the position it does. So A, you've got a thermal store, so you've got some of the energy being transferred there. You've got some of it going into the elastic potential store, and therefore then pushing it back. So you could argue that elastic potential store should have another arrow, yeah, right over there, and then you should have kinetic store again. And you're right, because it would move. It would move. So you know, you would have that. And then the final one is the internal store. Now that's an interesting one because we've not really spoken about that. But when a train crashes, what do you hear? You hear a sound. Where does that sound energy go to? Well, it just goes into the surroundings, the internal store of the surrounding air. That's where the energy goes. So it comes from the train making that sound and it goes into the surrounding air. Any sort of noise, even me speaking now, okay, where is that energy going? That energy is being transferred into the internal store of the surrounding air. Now that's really important because that will come up a lot. Okay, so that's the train. Now the car. So I asked you, the car is accelerating from a standstill. There we go. There we've got the car. Now what's occurring here? Now, for a car to move, it needs to burn. I put in inverted commas. It needs to combust the fuel. Okay, so the fuel is the chemical store. Okay, that's what you start off with. So there we go. You start off with a chemical store. Now, that will cause the vehicle engine to become warm, hot, and therefore a thermal store. Yep, because the combustion of the petroleum or diesel, I'm not sure what it is for that car, will be occurring, and that is a thermal store. Okay, that's the vehicle engine. When the car starts to move, the energy will be transferred from the thermal store into the kinetic store. Yep, and therefore it would start moving. However, like I spoke previously, it makes a noise. Cars aren't quiet. So where does that go? Well, at the point where that vehicle engine switches on, some of the energy transferred is being transferred into the internal store of the surrounding air. So that's where it's going. So we've got the internal store again. And it's really important that we understand that there is always an internal store. Nothing is 100% efficient. Well, I say nothing is 100% efficient. Nothing in terms of these descriptions will be 100% efficient. There might be some scenarios where you can get 100% efficiency. The likelihood is that you'd need some sort of, I'm just thinking off the top of my head, like a vacuum with your pendulum that would allow 100% efficiency of energy transfer, but it's very, very unlikely that we can achieve 100%. You can get as close to it, but it's unlikely because you'll always lose if you make sound or if you produce heat as a byproduct. Or thermal energy as a byproduct, then that's what will always happen. So they're your two examples that I worked through. Now, what I want you to do, final thing that I'd like you to do, is I want you to describe the energy transfers and stores in a light bulb as it is switched on. So we've got a light bulb, it's connected to a cell, and there are 1, 2, 3, 4, 5 blanks. Now remember, I want you to name me the store. So there's 3 stores, and then name me how it gets transferred. Now remember, there's 4 ways of transferring energy. Okay, 4 ways of transferring, 4 pathways that we can transfer energy. I want you to come up with those. And again, I will give you 30 seconds to write those 5. So, what have we got? Well, hopefully we've got what you can see in front of me. So, in the battery, it's a chemical store. Yep. And it gets transferred. So that chemical energy store transfers some of that energy electrically in the wires to a thermal store because you can feel it. So it transfers it to a thermal store. It then transfers it by radiation into the thermal store of the surrounding room. Okay, so you start off with a chemical store. There's transfer electrically into a thermal store, and then by radiation into the thermal store of the surroundings. So if you touch a bulb, for example, you'll feel that it's warm. Where does that energy go to? That energy is being transferred into the surroundings. That's where it goes to, and therefore the temperature of the surroundings will start to increase. Right, so that's the end of that lesson. It was conceptually quite a difficult one, and I think it's really important that you go back, if you didn't understand it, to go back and re-go through it. It's very, very important, because if you understand it now, it makes it much simpler for you to understand how we build on this in year 9, 10, 11 in particular. Okay, so firstly, answer the 10 multiple choice questions that follow this presentation. That will test your recall. Task 2, describe in no more than 150 words how the energy is transferred from within an electrical lawnmower. Okay, so you've got a lawnmower. Think about the energy stores, and it's an electrical one. So it's a plug-in one. That should hopefully give you an idea. And the extension task, I spoke about it a few times, but under what conditions can you have 100% efficient energy transfers? Is it possible? And under what conditions? Okay. And this final slide is the summary notes. The key things that I want you to take away from this lesson: A, the energy stores, you need to know them. B, the energy transfers, they're the pathways in which energy stores transfer their energy. So from chemical, it could be via the heating pathway into kinetic. And also the law of conservation of energy. That is something you need to know verbatim, which means you need to know word by word pretty much. So energy cannot be created nor destroyed. It can only be transferred from one store to another. Okay, well, I thank you for joining me. This is the second lesson of energy. We are going to stop with the energy lessons currently. We will come back to the energy lessons. One hopes that we can continue energy in school. Remember, we're in July. We're very close to the summer holidays now. But energy lesson 3 hasn't been decided upon at the point of this recording. So hopefully we'll come back to it in September. That is the plan. I bid you farewell, keep safe, and do look after yourselves.